Well, thank you again for doing this with us. We really appreciate it. And I wonder if we could just begin by asking you to just, you know, tell the visitor your name, who you are, and maybe very briefly explain to them, your expertise and your interest in large language models and chatbots.
Sure. My name is Emily M. Bender. I'm a professor of linguistics at the University of Washington. I work in computational linguistics, which broadly speaking is getting computers to deal with human language. And large language models are one piece of technology that involves getting computers to deal with human language.
Perfect. Thank you. Um, so my next question for you is that it seems like some of the biggest questions about large language models and chatbots are about meaning and understanding. So, like the question, do chatbots understand what they're saying? So, I was wondering if, in kind of the simplest way that we can manage, could you explain to people how linguists like yourself approach these concepts of meaning and understanding?
Yeah, so these are great questions. So, from a linguistic point of view, the important thing about a language is that it's a system of signs, and a sign is a pairing of form and meaning. So, a word is a sign. Cat, for example, is a word, and it's got both a form, so you can pronounce it cat or you can write it down CAT, and it's got what it means, which is, a cute furry animal, let's say. And those two things are separate, but they're linked in the word. And the thing about language models is that what they're doing is they are manipulating those forms and then spitting them back out in plausible sequences if we set them up as chatbots. But any meaning that's there is all on our side. There's a lot more that I can say about that, but I think you want that in a separate
Yeah,
question.
probably. Yeah. Um, well, I wanted to ask you about this paper that you co authored in 2020 titled Climbing Toward NLU. And in that paper, you use this thought experiment about an octopus to reach some pretty strong conclusions about large language models and chatbots based on them. And I wondered if you could, briefly tell your visitors, about this octopus thought experiment.
Sure. So, the purpose of the octopus thought experiment is to show that it doesn't matter how much intelligence is behind the language manipulating system. If that system only has access to the form of language, it doesn't have a hope of getting to the meaning. So, we came up with this story where we have two speakers of English who are stranded on two desert islands that happen to be connected by a telegraph cable, and they are mutually aware of each other. And so they start sending each other messages. They happen to both know Morse code. So they're sending back dots and dashes. And then deep underwater, there's this hyper intelligent deep sea octopus. And octopuses are smart animals, but we're making this, hyper intelligent because that's not the issue. That comes along and taps into the cord. And so it can sense the dots and dashes and picks up the patterns of the dots and dashes. And not only is it intelligent, it's also mischievous. And so at some point it cuts the cord and it starts sending back dots and dashes to one of the speakers. And initially, that person has no clue what's going on, right? Dots and dashes are still coming back. They're still interpreting them as if they were coming from the other person on the other island. And they might say something like, wow, what a beautiful sunset. It reminds me of lava lamps. And so they're putting in the dots and dashes for those English words. And according to the long history that the octopus has observed, a good sequence of dots and dashes to send back are the ones that encode um, yes, it's so beautiful. I can't imagine a more lovely place to be stranded or something, right? The octopus doesn't have that idea to communicate. It has its own ideas. It's an octopus. It has its octopus ideas. Um, but the dots and dashes that it's sending back are just the ones that are likely given the training corpus so far and what A has just said. And then we have another scenario where that first speaker A might say something like, I figured out how to make a coconut catapult. Let me show you how. Um, and describe something with, making twine and using coconuts. And the octopus, of course, has no referent for any of that, doesn't know what any of it means. But in that kind of a situation, the other speaker might send back something like, cool idea, great job, or something. So that's what comes back. And then the sort of punchline of our thought experiment is we have a bear appearing magically on that first island. And the person says in dots and dashes, help, I'm being chased by a bear. All I have is a stick. What should I do? And that's the point where if that person survives the bear attack, they're going to figure out that the octopus has not been understanding anything and is not, in fact, the person that they thought they were communicating with. So the point of all this is that it is possible for a system that can do a lot of computing of patterns to come back with further sequences of words that match what's going on, because that's a plausible sequence of words. But all it's doing is manipulating form, and it has no way to map that out to an understanding of the world or an understanding of the thoughts of the other speaker.
Thank you. Um, well, so I wanted to get into some of the conclusions that you and your co-author drew from that octopus thought experiment. And when I was reading the paper, what I was getting out of it was that this idea about the intention, that the the two human speakers, if you will, they have intentions about what they're trying to communicate to the other person, but that it seemed like the octopus, large language models and chatbots neither have intention, their own intentions, and they also don't have access to anybody else's intentions, and therefore they can't understand. Is that at least partially right? And I just wondered if you could walk the visitor through this whole issue about intentions, meaning, and the accessibility that chatbots have to intentions.
Yeah. Um, so, in order to make the argument that a large language model isn't understanding, we have to define understanding. In order to define understanding, we have to define meaning. And so, in that paper, my co author Alexander Kohler and I say that meaning is a relationship between the form of language and something outside of that. And that something sort of comes in two parts. There's what you might call standing meaning. So the word cat means something to English speakers all around the world, and it's sort of a range of things it might refer to. And then there's communicative intent, what I mean to be conveying by saying cat in some specific instance. And that's going to be maybe the cat that just walked by. Maybe I'm talking about a lion this time, and I'm referring to it as a big cat, and so on. And all of that is contextual. So the meaning relation is a relationship between the form and something outside of language. And eventually it grounds out in communicative intent. That is, what is the speaker trying to convey by choosing those words? And the thing about a chatbot or a large language model is it's not set up to model communicative intent. It's set up to model the distribution of word forms in text. And it can do that really, really well. And because there are so many patterns in the way we use words, and those patterns come from both grammar, right? The things that are grammatical to say versus ungrammatical, and then also the world that we live in physically, the world we build together socially, all of that's reflected in patterns of language. So the chatbots can keep reflecting those back. And we will make sense of it. But it's not that the chatbot has any communicative intent of its own or that has any ability to understand our communicative intent.
So in a way that, yeah, in a way that they're not even, their responses aren't even kind of an answer in a kind of a traditional sense of what an answer might be. It's and that we see them as an answer, some sort of a projection.
Yes. I have an example I like to use to make that
Oh.
concrete that involves the toy, the Magic 8 Ball.
Uh-huh.
So Magic 8 Ball was a toy made out of plastic with some liquid in the middle and some dice in it. And on those dice, there was things like signs unclear, ask again tomorrow, or definitely yes, or definitely no. And you would play with it by asking a question, shaking it up, and then looking at what side of the dice comes up. And the thing about it is, if you said, is it going to rain today? And it said, signs unclear, ask again later, fine. If you shake it up and you say, what should I have for lunch? And it says, definitely yes, that's an incoherent discourse, right? So we very quickly learn in playing with the toy that you can only ask it yes no questions if you want to have a successful conversation. Conversation in quotes. So we ask it yes no questions so that we can make sense of the words that we see coming back. And we're doing the same thing with chatbots. We are telling ourselves a story as we put an input into the chatbot so that we can use that story to make sense of what comes back.
Wow, that's great. Thank you. Um, and I guess that in that paper, I was also struck by this line where you called any reasoning, by the large language or the chatbot a mirage. And I
Mhm.
just wondered if you could kind of unpack that idea of mirages related to chatbots a little bit.
Sure. So, our primary evidence of large language models understanding us is that plausible, coherent language comes back that seems to be a continuation of what we put in. It's a mirage because we are doing all of the meaning making there. We are using our own linguistic capacity, which crucially involves imagining the mind behind the text, to make sense of that text that has come back. And in the process, we have imagined a mind that, in the case of the chatbots, isn't there.
Great. Well, I wanted to turn to another important paper from 2021 that you were a co author on, called On the Dangers of Stochastic Parrots. Can Language Models Be Too Big? And I would love it if you could really help the visitor understand what you and your co authors and other people mean by a stochastic parrot.
Sure, yeah. So, in the paper on the dangers of stochastic parrots, can large language models be too big? Parrot emoji is part of the title. Um, we introduced the phrase stochastic parrots as a way to make vivid what it is that large language models are doing. So instead of listening to the input from the user, thinking about it, coming out with a plausible answer, they are stochastically, that is, randomly but according to a probability distribution, parroting back things from their training data. So it's not that they have specific things memorized and they're only giving memorized responses. Um, that's what stochastic is doing in there. It's saying basically, according to some random chance, but with information about the probability distribution that came from the training data, come back with forms from the training data. And parrot is, despite the fact that we use the parrot emoji and it's fun to point to the animal, it's actually more about the English verb to parrot, which is to repeat back without understanding.
That's great. Thank you. Um, well, in as I was reading the paper, and in particular the section that kind of concentrates on the stochastic parrot uh, notion, um, it seemed like that the main danger that you and your co-authors were pointing out is kind of like a contemporary version of the Eliza effect,
Mm-hmm.
in which users are essentially projecting a bunch of stuff onto the behavior of the computer. In this case, projecting onto the text created by these systems all sorts of reasoning and intent and understanding that they lack. Is that right, do you think? And if not, or even if it is, could you just kind of walk the visitor through, what is dangerous about a stochastic parrot?
Sure. Yeah, so the paper title is On the Dangers of Stochastic Parrots, and it was written in large part because the other lead co author, Dr. Tunique Gebru, noticed in her environment, she was working at Google at the time, that there was just this drive to making language models bigger and bigger and bigger, and nobody was thinking about what might go wrong. So this paper is sort of a collection of pointers into the research literature on what might go wrong. And one subpart of that is that if we have the ability to convincingly create synthetic text, then that can cause problems. It can cause problems when somebody is interacting directly with the computer and they think that it is thinking and reasoning and knowing lots of things instead of just representing the distribution of word forms and text. That might lead people to trust the output and consider it factual when it's not factual. And a subcase of that is in these very large training data collections, you have a lot of systems of oppression reflected as bias. And so these things will come back, and it will sound like if you believe this to be a reasoning and, in quotes, objective because it's a computer, it'll sound like this smart computer believes all these terrible things, and so maybe therefore they're true. So that's one collection of dangers. Um, Another collection is people might say, yeah, this is a reasonable way to create a robotherapist or robo-lawyer, and so on. And we're seeing people getting in trouble for doing that now. Didn't We didn't really think as we were writing the paper that folks would be so excited about synthetic text, and unfortunately they are. Um, and then another kind of problem is when the person who's encountering the synthetic text is not the one directly interacting with the chatbot, but somebody has used it to create something that looks like real text and then it's not clear where it came from. For example, there were some fake mushroom foraging guides that were posted on Amazon as books for a while that were just the output of one of these text synthesis machines. And that's really frightening. And some poor person coming along who's interested in learning about mushrooms might pick one of those books because how are they going to tell unless we have a clear signal about what's synthetic and what's not?
Great. Um, I know that there's been there have been some people who have pushed back against this notion of stochastic parrots and argue that advance some sort of counter argument that that these systems are more than a stochastic parrot, and I guess have emergent properties where they have models of the world or um, some sorts of reasoning abilities. I wondered if you could just talk to some of the criticisms of the stochastic parrot thesis, I guess you could call it, and what you make of those criticisms of the stochastic parrot.
So I will frequently see people saying, well, this means that it can't possibly be a stochastic parrot. And then they're pointing to some particular research result. So, for example, there was a large language model trained over Othello board games that was able to produce legal Othello moves. And then if you look inside at the connections within the neural network, there were pieces that were found to correspond to something about board configurations. And to that I say, sure, wonderful, interesting. You can build a model of a very constrained artificial world that is transparently represented in the textual version of that artificial world by modeling the text. But that's not the same thing as what happens in linguistic meaning. You will also see people very excited about the ability of the current chatbots to take something written in English or some small collection of other natural languages and output corresponding computer code. Um, and where does that come from? Well, it comes from training data that pairs natural language descriptions with computer code descriptions. Also, not surprising. You get to see people very excited about chess playing in these systems. Well, it turns out that there was a bunch of chess games in the training data. So, sort of what I'm coming around to is a lot of these claims of emergent properties are based on systems trained on closed data sets. And if we don't know what's in the data set, then we can't make any claims about what's emergent versus just a finely captured model of what was in the training data.
Hmm. Okay. I was wondering too. I would. This isn't a question. It's kind of like calling an audible question. So forgive me as I fumble around to get it out. But it's about scale, and I think
Mm-hmm.
that I'm not sure that people, um, including many experts, actually really can have an intuition for the scale of the training data, the scale of the number of parameters in these systems, um, the amount of computation that goes into training them. Um, I just wondered if you had thought at all about this issue of not really appreciating the scale of things that goes into training them to kind of interpret their performance. I guess part of
Mm.
the mirage, I guess, idea.
Yeah, yeah. I think so, do you remember the game we used to play with the predictive text on cell phones, where you would type in something like, I'm sorry I'm late, I have to, and then just pick the middle option until it hits the end of a sentence, right? And those were amusing, and nobody thought that the phone was doing any thinking or making any predictions about the world. It was just a reflection of how you use your phone. And people would post this as a meme to sort of say, well, my phone says I have to be late because I have to go to the grocery store, but yours said you have to be late because you have to walk the dog, or other more revealing things, right? And that's just a reflection of the fact that we have little local language models inside our phones, but they are only doing, n-gram or very, very small language modeling because that's what's going to fit in the computational power of a phone. What I think we have a hard time appreciating is how much apparent fluency we can get out of the enormous scale of both training data and compute put into training time. Um, let me say that again so we don't have to have the cat. Um, what I think we have a hard time appreciating is the apparent fluency that scale can buy us. So if you get lots and lots of training data, lots and lots of compute, then instead of something that can sort of quickly get into a cycle where it says something like, I have to walk the dog and walk the dog and walk the dog, and it's clear that it's really not all that clever, let's say, you can get something that is very, very flexible in its output and uh, connects with all of our linguistic processing capabilities. And so we get sort of recruited into the apparent intelligence of the system, and we don't have good ways of taking distance from our own cognition as we try to evaluate the output of these things.
Hmm, that's really interesting. Um, well, I wanted to ask you some. No wonder you
Okay,
kept using
go.
cat as your example.
Oh, yeah,
Um,
there's two of
yeah.
them. This is the second one.
Well, I wanted to ask you some questions about issues. I think of these next questions are kind of issues that boil down to issues of trust around these systems, and I just wanted to get your kind of take on these trust questions. Um, the first is it's nice to have the cat back there. There's
I'm not going to try too hard. This is going to be an ongoing battle.
Um, well, I would just wondered if you could help the general public visitor understand the issue of explainability that is there with today's large language models and chatbots based on them.
Yeah. So if you are looking at a large language model as just a model of language, so why is it that it picked this word as a likely one to come next? Then I think you can do explainability looking at model weights and parameters and its training data and so on. If you're looking at the large language model incorrectly as an information access system, where you are asking it a question and taking the sequence of words that comes back as an answer to your question, and then you want it to explain how did it come up with that answer, um, that's a fool's errand because it didn't come up with an answer. It came up with a sequence of words that's a continuation of what you put in. But there will be times where people propose asking the language model for an explanation of its answer, which then, you have given it another input sequence of words. It will come back with another sequence of words that looks like an explanation because that was the specification. That was, a likely continuation is going to be something that looks like an explanation. Um, and it is a big mistake to take that as actual explainability for how it came to the answer because it wasn't an answer, it was a continuation.
That's really interesting to me because it's that's very helpful for me personally answer because for this issue of explainability, I always thought my immediate responses were all the weights are there, all the it's a very determinative system. You put in this input, it ran through a function that's completely explicit, and then you have an output. So that the model is its own explanation in a way. But yeah, that explainability only becomes a bigger issue if you're attributing it these capacities that maybe are a mirage. That's interesting.
Yeah.
Um, and well, I guess this will be kind of a similar question. What about their production of, these what turn out to be falsehoods, stated with conviction? Could you talk a little bit about that phenomenon?
Sure. Yeah. So people will frequently talk about language models hallucinating, and I think it's a problematic term because hallucination suggests that the model's having an experience, a false experience, and then reporting that false experience, which is not at all what's going on. There's another problem there, which is when the sequence of words output by a large language model matches what we believe to be true of the world, we say that is correct. And when it doesn't match, we say it's incorrect. But the language model is doing the same thing in both cases. It's coming up with a plausible continuation in text to the input that it received in text, period.
Okay, great. And we talked about some of the bias and bigotry that's revealed in the text that they generate. Um, what about issues of privacy and security for people using these systems and these chatbots?
Yeah. So if you have a language model running locally on your own machine, you are not going to run into privacy issues. But that's not how things work at the scale that's going on, right? You need cloud compute, you need OpenAI's very large model or Google's very large model. And so in order to interact with it, you have to upload the text prompt that will serve as the input that will then produce the output continuation. And so I think it's worthwhile for people to think, what am I sending into whose cloud as I am typing things to these chatbots? So that's a privacy issue. There's also security issues as people use these to get quick boilerplate code, for example. Well, are you really in a position to check that code to make sure that it doesn't have security flaws? And there were stories of, with Python in particular, ChatGPT making up non existent libraries and then bad actors catching those names that ChatGPT was making up and creating libraries that match them.
Yeah. Okay. That's wild. I hadn't heard that before. Um, well, I just, how important do you think some of these kinds of issues about trust? How important do you think these issues about trust are to kind of the future trajectory of the use of large language models and the use of chatbots?
Yeah. Um, so when we talk about trust, trust is a relationship, right? It's a relationship ideally between people or organizations of people. And if some organization is going to set up a chatbot to represent it, to talk to people, then that organization had, I think, better be pretty careful about what kinds of things it allows the chatbot to say and how transparent it is about the chatbot and the chatbot's limitations. And right now we have chatbots that can say anything, right? They're very flexible, they're trained on lots and lots of text, and so they are probably not a good technology for very many use cases. Fun example from Watsonville, the Chevrolet dealer had a chatbot that was based on ChatGPT. Some users figured that out and started asking it coding questions, and it is trained to answer those things, and so it answered the coding questions. And I'm sure that Chevrolet of Watsonville was not pleased to be paying OpenAI to answer random people's coding questions, right? But it gets worse. Someone came up with a prompt that caused it to say yes, no takesies, backsies to any input, and then asked it to sell the person a new SUV for $1. And it comes up with, yes, this is a binding contract, no takesies, backsies. And this is reported in Business Insider a couple of months ago. So if you want an automated system in between, let's say, the company client relationship, that automated system had better be pretty buttoned down to only say things that are appropriate and to have its limitations be very, very clear. There's another issue of trust, which is if we have synthetic media flowing through our information ecosystem that looks just like authentic media, and in some cases is even published by erstwhile journalistic outfits like Sports Illustrated is posting a bunch of this now. It is going to become much harder to find trustworthy, authentic journalism and to trust it when we've found it. And that's a huge problem.
Hmm. Um, well, just kind of switching tack. Is there, from trust for these issues of trust, are there uses of chatbots or large language model LLM technology that kind of excites you, that you think is, sort of, yeah, interesting, exciting, that sort of thing?
Um, So the original purpose of language modeling technology was classificatory or discriminative. So basically, if you had the output of an acoustic model in a speech to text system, it's going to give you a bunch of possibilities. And the role of the language model was to pick the one that looked the most like the language you were trying to transcribe. There's a similar use case in machine translation. You go from language A to language B. There's a bunch of things that might be in language B. Well, which one looks the most likely? And this is going to smooth out like agreement between subjects and verbs and so on. So that is extremely useful. I think the language models have overshot the size that's really optimal for doing that. I think we're building things that are too big. One of the main points out of the Stochastic Parrots paper was these things are too big to document. If we don't know what's in the training data, we shouldn't be using them because we don't have a good way to understand and then mitigate the risks of the various biases in that training data. So in terms of language modeling as a technology in general, yes, I like automatic transcription. I like to use machine translation. I like spell checkers, right? All of these things are applications of language modeling technology. In terms of synthetic text being extruded from chatbots, I don't see very many good applications of that. Um, in many, many cases, I would prefer to have something much more tightly constrained, like a menu. If you're talking about information access, I don't want a chatbot telling me the answer. I want a search engine helping me find a web page where there's a person who has some accountability for that answer, and I can locate it in terms of how I understand that information to relate to other information. So, no, I'm not very excited about chatbots in general, but language models have a place.
Great. Why are some people talking about sort of apocalypse and human extinction in connection with these sort of systems, while other people are talking about some sort of utopia in our future? I just wondered, what you thought of those conversations and how you think people should approach this kind of discourse.
Yeah. So both AI boosterism and AI doomerism are different varieties of AI hype. They are different ways of saying this technology is infinitely powerful. And then some people imagine from their luxury communism where nobody has to work and we all have all of our needs met. And some people imagine the end of the world, the apocalypse. And they set themselves up as being opposing ends of the same spectrum. But in fact, they're two sides of the same coin. And it is all predicated on the belief that because we now have systems that can output plausible sounding text on just about any topic, therefore, and here's the big jump, we are about to have some kind of artificial general intelligence that not only can do anything a person can do, but it can improve itself and get better and better and better. And, there goes the singularity or whatever it is. There is really nice recent work by Dr. Tamik Gimbru and Dr. Emil Torres looking at how that way of thinking is embedded in what they call the TESCREAL bundle of ideologies. TESCREAL is an acronym, and it basically traces back to things like transhumanism and eugenics. And it is all really, really unpalatable. And I think we are far better off thinking about automation as a tool and thinking about building automation to do the things that it is useful to automate while keeping an eye on what could go wrong if we let an automated process make decisions without accountability and without recourse if you are on the losing end of one of those decisions.
Well, I guess thank you. And a related question about that is, you know, are we worried about the right things, concerning these technologies? Are we both worried about and hopeful about the right things with respect to these technologies?
Yeah.
Um,
I think the AI doomerism discourse is misplacing a lot of effort and a lot of regulatory attention away from what we should be worried about. So we should be worried about things like the reproduction and amplification of systems of oppression through automated systems. We should be worried about automated decision making where people don't have recourse or don't even know that this has been happening in the background. This is things like allocation of social benefits, but also automated interview systems, which purport to listen to what you've said and make judgments about how suitable you are for a role, but in fact have been shown to give similar answers regardless of what language somebody is speaking. So they're not listening to what you're saying, right? We should be worried about the energy use and carbon footprint of this. We should be worried about the centralization of power, where the model is you can only do this work if you get very, very large data sets and very, very large compute, and everybody else is locked out. We should be worried about, did I say this one already? We should be worried about the impact of the information ecosystem if we have lots of synthetic media flowing around that we can't easily identify and clean up. I don't think we need to be spending any time worrying about a pile of linear algebra combusting into consciousness and deciding to destroy the world.
um, well, I guess maybe we have time for two last questions. Um, I have heard this quip that when you hear somebody say AI, start looking for the people. And I wondered if you could talk about your perspective on this sort of the labor aspect of these
Yeah,
systems.
yeah. So in many ways, what gets called AI is actually just a interface that allows people and businesses to access the labor of people as if they were automated components. And this is the idea, for example, behind Amazon's Mechanical Turk. And it is terrible working conditions for the people doing the labor. It is bad for sort of job security, because the more you can atomize tasks and make them available in a gig economy basis, the less job security anybody has. Um, and also, it makes the labor very globalized. So you can end up with a race to the bottom on wages. So all of that is really important. And some of this isn't just the kind of labor that we often do for free in a CAPTCHA, right? Every time you are picking the stop signs in that grid of pictures, you are in principle helping to train autonomous vehicles, right? Um, so some of it is just free labor that we end up doing because it's in between us and the thing we're trying to access. But also there's some of it that is really, really atrocious. So in order to make ChatGPT something that doesn't output, violence and all kinds of awful imagery that OpenAI didn't want to be caught subjecting people to, they did this second phase of training called reinforcement learning from human feedback, a bunch of which involved basically having people look at the bad output and not only say this is bad, but say what kind of bad it was. And this was outsourced to workers in Kenya, who had pretty precarious labor conditions, who were not paid very much, and who certainly did not get the kind of psychological support you would need if you were going to be doing that kind of work.
Great. Um, okay, let's see. Maybe my last question is just again, thinking about our visitors, if you had one thing that you would like them to walk away from this exhibit knowing about chatbots and large language models, what would you like to what would you like them to the one thing you would like them to remember or walk away with? Yeah.
When a large language model outputs something that seems to make sense, you are the one making sense of it.
Okay. Great. Well, thanks. I don't want to go right up against the clock, but thank you so much for doing this with us.